Assalamualaikum and hi everyone. Glad to see you again. These are the subtopics that you are going to learn today. Do you know what is the meaning by the word mole? Mole can be defined as the number of atoms in 12 grams of carbon-12. Just like a dozen of anything is equal to 12 of anythings. A mole is equal to 6.02 times 10 power of 23 of anything. The quantity of 6.02 times 10 power of 23 is referred to as Avogadro's numbers in honor of an accomplice to Italian scientist named Amedeo Avogadro. We can conclude that a mole is a measurement of the amount of something. A mole represents a really big number of a lot of something. It doesn't make sense to use mole to talk about most things, but it's really good unit when we want to refer to a specific number of atoms. Because an atom are too small and we need a very large number of them to see them. The mass of 1 mole of an element, also called molar mass, will be equal to that element's average atomic number, which can be found in periodic table. 1 mole of a substance is quantified by the following means. Let's do this exercise together. Quinine, a compound extracted from cinchona tree, which is traditionally used to treat malaria. If given a 1.08 gram of quinine sample, calculate the molecular mass of quinine, the number of mole of quinine, the number of molecules of quinine, the number of hydrogen atoms, and the mass of carbon atom in grams. For question A, calculate the molecular mass of quinine. Given in the question, molecular mass of quinine and the mass of quinine. You have to find out the atomic mass of carbon, hydrogen, nitrogen, and oxygen from the table of relative atomic mass. So here is the calculation of molecular mass of quinine. The molecular mass of quinine is 324 grams per mole. Molecular mass is also known as molar mass. For question B, you can calculate the number of quinine by using the formula of number of mole of quinine equals to mass over molar mass. Next, you substitute the mass of quinine and the molar mass of quinine. Therefore, the number of mole of quinine is 3.333 times 10 power of negative 3 mole. So please remember, for the number of mole, you have to take 3 to 4 decimal place. For question C, calculate the number of molecules of quinine. As we already know, 1 mole is referred to 6.02 times 10 power of 23 molecules. For this type of question, you have to solve it by using stoichiometric method. So you can write like this. 1 mole quinine is equivalent to 6.02 times 10 power of 23 molecule. The symbol that you have to use here is equivalent to. From the previous calculation, the number of quinine is 3.333 times 10 power negative 3 mole quinine. And we represent the number of molecules by X. You must use the symbol here is equal to. Next, you can find out the value of X. Therefore, the number of molecule is 2.006 times 10 power of 21 molecules. The unit here is molecules because question asks number of molecules. Okay, for question D, calculate the number of hydrogen atoms. From the previous calculation, the number of quinine is 3.333 times 10 power of negative 3. For this question, you have to calculate in 2 steps. Step 1, calculate the number of mole of hydrogen atoms. The second step, you can calculate the number of hydrogen atoms. So you can write like this. 1 mole quinine equivalent to 24 mole of hydrogen atom. But how do we know the mole of hydrogen atom? So you can find out from the formula of quinine. Okay, for in this question, number of mole of quinine is 3.33 times 10 power of negative 3 mole. Okay, so we represent the mole of hydrogen atom as X. So you can calculate the value of X. Hence, the number of mole of hydrogen atom is 0.008 mole. For the second step, you can calculate the number of hydrogen atom by relate mole with Avogadro's number. So you can write like this. 1 mole hydrogen atom is equivalent to 6.02 times 10 power of 23 hydrogen atom. Okay, from the previous calculation, the number of hydrogen atom is 0.08. So we can calculate the number of hydrogen atom by 0.08 times 6.02 times 10 power of 23 hydrogen atom. Therefore, the number of hydrogen atom is 4.816 times 10 power of 22 hydrogen atom. Okay, for the final unit, just follow the questions. For question E, calculate the mass of carbon atom in grams. For this calculation, it involves 2 steps. The first step, you have to calculate the number of mole of carbon atoms. Okay, as we already know, 1 mole of quinine consists of 20 mole carbon atoms. Okay, from the calculation, we already calculate the number of mole of quinine, that is 3.333 times 10 power negative 3 mole quinine. And we want to find out what is the number of mole of carbon atoms. Okay, so we can calculate 20 carbon atom times 3.333 times 10 power negative 3 mole. And we can cancel out the unit, the same unit. Okay, therefore, the mole of carbons is 0.06666 mole carbon atom. Okay, to calculate the mass of carbon, we can use the formula of mass of carbon atom equals to moles times molar mass. Okay, therefore, the mass of carbon atoms present in quinine is 0.7992 grams. Don't forget to write the final unit in grams. Now, we move to the second question. 250 ml of 2.0 molar hydrogen peroxide H2O2 decomposes to produce water and oxygen. The reaction equation is as follows. What would be the volume of oxygen released at STP and room temperature? Okay, so STP means here standard temperature pressure. Okay, first of all, you can take out all the information given in the question. So already given in the question, the volume of peroxide, that is 250 ml, and the molarity of hydrogen peroxide, that is 2.0 molar. So molarity is also known as concentration. Okay, question 1 to ask you, okay, what is the volume of oxygen at STP and room temperature? Okay, from the data given, okay, right, so we can use this information to calculate the number of mole because the formula of molarity is equal to moles over volume. Okay, so we can find out the number of mole of peroxide. Okay, next you can substitute all the values. Okay, so molar is referred to mole per liter. Okay, therefore the unit of volume you must convert from ml to liter so that we can cancel out the unit of liter. Okay, so therefore the number of mole of peroxide is 0.5 mole. This is the sample of calculation for the molar volume of gas at STP and room temperature. From the previous calculation, we already calculate the number of mole of hydrogen peroxide, that is 0.5 mole. Okay, the question asks to calculate the volume of oxygen at STP and room temperature. However, in the question, it's not given to you the mole of oxygen gas produced. Therefore, the first step, you must calculate the number of oxygen gas released. How that we can calculate the number of mole of oxygen gas released? You can use stoichiometry method. So, from the equation, okay, based on the equation, there are 2 mole of hydrogen peroxide that produce 1 mole of oxygen gas. So, you can write the stoichiometry like this: 2 mole peroxide equivalent to 1 mole of oxygen. So, this stoichiometry is come from the equation. Okay, next. Alright, so we can substitute the number of mole of peroxide. Okay, and then we can find out the number of mole of oxygen. Okay, so 0.5 mole divided by 2 mole. Okay, right, therefore the number of oxygen gas produced is 0.25 mole. Okay, next for the calculation STP. Okay, so you must remember at STP, 1 mole of oxygen gas is equivalent to 22.4 liter. Okay, but from the previous calculation, there are 0.25 mole oxygen gas produced. Okay, so just substitute the value here. Okay, and then we can find out the volume of oxygen gas produced at STP, 0.25, okay, 0.25 times 22.4 liter. Okay, therefore we can cancel out all the units, the same unit, and the volume of oxygen at STP is 5.6 liter. Okay, for the volume of oxygen at room temperature, okay, so we can relate 1 mole oxygen is equivalent to 24 liter. Okay, as for 0.25 mole of oxygen is equal to, okay, so 0.25 mole times 24, and we can cancel out the same unit here. Okay, therefore, the volume of oxygen gas released at room temperature is 6 liter. Okay class, that's all for today. Remember, practice makes perfect.